Good evening, students. This is Tuhin sir again. It's been a while since I made my last video. This is again a pulling and pushing problem from Pathfinder JE Advanced. I had forgotten to mention that the previous question that we had done on pulling and pushing involving friction was also from a Pathfinder book. So you can see the question. There is a force P which is horizontal. A block of mass m rests on a rough surface, and there is a force Q in addition to force P, which is at an angle of theta with the vertical. The question asked is, what is the minimum value of mu for which the block will remain in equilibrium? And the options are A, P plus Q sin theta, by mg plus Q cos theta, B, P cos theta plus Q by mg minus Q sin theta, C, P plus Q cos theta by mg plus Q sin theta, and D, P sin theta minus Q by mg minus Q cos theta. So these are the four options. We are required to tell which is the correct option. So I am rubbing this part. If you can recall lectures 1 to 4, particularly lecture 3 and 4, which involved pulling and pushing, it has already been mentioned, and it must have been clear that the limiting friction that the surface can apply will not exceed the horizontal pushing force. Okay, so there you have a horizontal pushing force of P towards the right, and let me also give a value of mu. Resolving Q into its components, this will be the horizontal component pushing the block forward will be Q sin theta, and the vertical component down will be Q cos theta. mg is the force with which Earth attracts the body down. Normal reaction force will be the reaction force by the surface on the block. As we have discussed twice before in my earlier two videos, for the body to remain on the ground in contact with the surface, the net force in the vertical direction, which is the y-axis, has to be the same, which is the force downward should be equal to the force acting upward, which means in this case mg plus q cos theta should be equal to the normal reaction force. And from definition, friction limiting is mu n, which is mu mg plus q cos theta. And what is the pushing force? The pushing force let me erase this part also. The pushing force towards the right, the net pushing force towards the right is equal to P plus Q sin theta. And the limiting friction force cannot exceed this, which means mu mg plus q sin theta, q cos theta cannot exceed, it has to be less than or equal to p plus q sin theta. So we have been asked what is the value of mu for which the body will stay in equilibrium. In this case, mu mg plus q cos theta, if I equate with p plus q sin theta on the right hand side, mu comes to p plus q sin theta divided by mg plus q cos theta. Or let me just rub it again. And so equating these two, I am calling it as equation 1. So what I get, the answer, mu is equal to p plus q sin theta divided by mg plus q cos theta. I hope I have been able to clear it, and please do subscribe. That will encourage me to make more videos. There will be a few more pushing and pulling problems. I will be solving a few more from possibly Pathfinder, a few from Allen, a few from Akash. But very soon I will be moving on to the inclined plane involving friction, and we will start with what is called as the angle of repose. And why is it called angle of repose? So thank you very much for watching, and please do subscribe.